So finish our talk about hydrocarbon, we cannot forget about alkynes. So alkynes is the last class of hydrocarbons. It's unsaturated hydrocarbon with a triple bond here between two carbons. So they are unsaturated hydrocarbon. The general formula of alkynes are CnH2n minus 2. The simplest alkyne is ethine or acetylene. The functional group here is the carbon-carbon triple bond. So this is a functional group of alkyne. The hybridization of the carbon that form the triple bond here is an sp hybridized carbon, and the shape of the carbon, the shape of the bond here is linear. So this bond angle is 180. So quickly, let's look at the hybridization state and the structure and bonding in alkyne as well, which we have already covered before in hybridization, but let's do a quick recap for this lesson. So again, the carbon has two electrons in the 2s orbital and two electrons in the p orbital. The p orbital has three suborbitals, 2bx, y, and z. So two electrons in one into bx and one into by. Now to form the sp hybridized orbital, there is one, the 2s orbital will combine with only one of the p suborbitals to give you two new hybridized orbital. Each are called sp orbitals. So the sp orbitals each will have one electron, leaving the other two p orbitals unhybridized, and they still gonna be called 2p orbitals, and each will have only one electron as well. So the carbon in the alkyne will be sp hybridized, and each sp hybridized orbital will have one one electron. It will have only two sp hybridized orbital and two p orbital which are not hybridized. So each of the sp hybridized orbital will have 50% character, s character, and 50% p character. That means the bond that will come out of an sp hybridized orbital will be even shorter than the sp2 or the sp3, because now it has more s character, so it's closer to the nucleus than the other orbitals. The two sp hybridized orbitals will arrange themselves as furthest away from each other in space, so they will be linear, and then the other p orbitals will be also perpendicular to the plane of the sp orbitals. So all the three will be perpendicular to each other in space. How the bonds are formed. Now, the head-to-head overlap between the sp orbital of the carbon here and the 1s orbital of the hydrogen will give you a sigma bond. So the two carbons each are sp hybridized. One hydrogen and one sp orbital from the carbon will give a 2 sigma bond. And then the sp orbital from the both carbons will have a head-to-head overlap as well to give you another sigma bond. So all of these are sigma bonds. Now we are left with two p orbitals. So each of these two orbitals will have side-to-side overlap with the corresponding p orbital from the other carbon to give two new bi bonds. So the triple bond of ethylene or of any of acetylene or of any alkyne will be formed of one sigma bond and two pi bonds. So this is how the structure of alkyne. Alkyne have also very reactive, and naming of alkynes follow the same rules as we said for alkenes. So if you want to name an alkyne, again, you have to look at the longest chain that has a triple bond, and you have to give it number where the triple bond here is given the lowest position. Look at the substitution and give them number, and then arrange them in alphabetical order. And don't forget to add the suffix "-ine" at the end of any alkyne. So now we reach the end of the hydrocarbons. We have discussed the alkane in the last lecture, and in this lecture we discussed the alkenes and briefly discussed the structure and bonding and naming of alkynes.